Hi, this is Tim from Tiger at Astronomy, and you are watching Adventures in Astronomy. Okay, so I've been doing a lot of Arduino based development lately, and I wanted to drop a few hints and tips that I've discovered, and some of these were pretty hard ones, so maybe you'll find these useful. So the first thing is I'm going to talk about versioning and GitVersion, but before we get into that, a quick word about a product called VisualMicro. Now you'll see that I'm using Visual Studio to develop my Arduino code, and I quickly got bored with the Arduino IDE because, let's face it, it's not very good at anything it does. It's a pretty poor editor. There's no IntelliSense. The color scheme's awful. It's just not a very good IDE, basically. So I have a Visual Studio background. I do most of my work in C# and .NET. And so I was over the moon when I found out there was a plugin for Visual Studio that enabled Arduino development. Now, there's also various products you can get for Visual Studio Code that do the same thing. But as I said, I'm a Visual Studio guy. That's my background. And even better still, there's a free version of VisualMicro. So everything I'm going to show you today, you can do with free products. So Visual Studio Community Edition is free. VisualMicro has a free edition. I've actually bought a license because I find it so useful. I wanted to support the project, so I've bought a license for it. So as you can see, I've got my Arduino code. Here's my .ini file. Open in Visual Studio, and this is glorious. I'm getting syntax highlighting. I get IntelliSense if I want to do, I don't know, serial.println or something. Look at that, I've got IntelliSense and I can pick serial from there, and I get completion and all kinds of stuff. There's just, if you do any Arduino development, why are you putting up with the Arduino IDE? Come on. Get Visual Studio Community Edition, get VisualMicro, take your Arduino code to the next level, okay? Because the other thing is I don't limit myself to some of the Arduino ways of doing things. I like to use the standard library, the C++ standard library, and on some of the bigger Arduinos, some of the maker boards, the MKR 1010 Wi-Fi, for example, they're easily capable of supporting that development model. So that's something to think about. What I actually plan to talk about is versioning, because in my I use Git version control, and I'm assuming as a developer you use some kind of version control, and almost everybody these days is using Git. So with GitHub being free, it's almost ubiquitous now. So I like my code to version itself. I don't want to ever have to type a version number into my code, because it's one of those little things, you forget to update it, you release stuff with the wrong version number in. So common sense says that you ought to be able to derive a version number for your code automatically from your version commit history, okay? And somebody else had that idea too, and they've brought out a product called GitVersion. Now, I just want to pop into PowerShell at this point, and PowerShell is my standard Windows command line at this point. So I'm in my project directory, okay? So there's my project structure that you can see on the other screen here. It's actually these files, okay? So and for this particular exercise, we need the GitVersion command line tools. Now, if I was using a C# project, there's a NuGet package that you can install, but that doesn't work because we're in C++. So you need to have previously installed the GitVersion command line tools for this to work. If we now just type in GitVersion, just like that, then that will look at my commit history and spit out a load of information. So it has decided that I am currently working on version 0.10. Okay, and because I'm on the develop branch, that's considered to be an alpha release, so I get the pre-release tag alpha.0, so it's no commits on the develop branch. And if you look at the full semantic version, where is it? Semver here. Okay, so this will be the full product version of my code, so 0.10-alpha.0. Okay, so what we need to do is somehow get that into the Arduino code so that it's baked into the firmware. Okay, so we need to do that as part of the build process, and notice this is a JSON document. Okay, so the open squiggly brackets and then it's key name value all the way down. Okay, so if we look at, I've got a couple of items in my project here that I've created ahead of time, I've created this little PowerShell script called generate version, and let me tell you, this is a good few hours of research right here. It looks simple, but a lot went into producing this. So this PowerShell script, let's just zoom out slightly, does what it says on the tin. It uses GitVersion command line tools to create a Version.h header file. Okay, now so there's a couple of parameters you can pass to this script. You can specify an output file, and it defaults to Version.h in the current directory, and you can pass the project directory, which is where GitVersion gets run, because GitVersion looks in the current directory for a Git repository, so it's important that you run the command in the correct directory where the Git repository is. Okay, and that just defaults to the current directory. So the first thing this does is push location project directory. So this saves the current working directory on the stack and makes the current working directory be whatever was passed into project directory, which defaults to the current directory, so that would be no change by default. Okay, and then the magic happens here. So we run GitVersion.exe, which is expected to be on the path, so we don't need to specify any path information or anything. And then we pipe the output from GitVersion, which, as you remember, is a JSON document. We pipe that into this PowerShell filter called convert from JSON. Then we can just dot into this GitVersion object we created here. We can now just dot into it and access the property. So you remember we had a semver property. So look at the PowerShell screen again, and see there's a semver property there. So what we're doing here is retrieving that property and putting it into the semver variable, and then the same for major version and the same for minor version. Okay, and then we write the output file. So if there's already a file there, we overwrite it, because set content overwrites the previous contents of the file. Path out file, and then we're just creating some const expressions in C++, which are sort of equivalent to hash define, but it's the more modern way of doing it. So we're creating these constant items called semantic version, major version and minor version, and the values of those will be set from whatever GitVersion decided. And then we just write something out onto the debug console. We pop location to restore the current working directory to whatever it was before we started, and we're done. Okay, so that's I think you can see the basis of creating a file called Version.h. So in order to wire this into our build, we can actually use a feature of the Arduino build chain. It needs to know what project we're in, so it's a bit context sensitive. Okay, here we go. So add code. So we can add a local board.txt, and this allows us to actually hook into the build process. Okay, so in our board.txt, resharper, edit, insert live template. Okay, generate version, there we go. Now, This relies on PowerShell, and it runs by default this generate version.ps1 script. Okay, so what we do is we're setting this build property called recipe.hooks.sketch.prebuild.1.pattern, and then this allows us to run a command of our choosing before the build happens. Okay, so we run PowerShell, and we make it a non-interactive PowerShell. We don't want to display anything, we don't want to load a user profile or anything, but we want it to run this file. Okay, so we're passing in the full path. So this is our substitution token here. Sorry, this editor's being difficult. This substitution token here resolves to our project directory, and so we want to go up to the solution. So that's ... means go up one directory to that. So that's the solution directory, and then the file name of the script, which is generate version.ps1, and then we pass in the project directory option to that script. If you remember, we could specify the directory where we wanted it to run and the output file. So we're passing in the project directory, and that is our project path again, and then the output file is our build path /version.h. Now the build path, when you build an Arduino project, it doesn't build the source files that are in your project directory. What it does is it takes a copy of all the files and puts them in the build path, and it also does the same with any libraries and so on. It takes a copy of all the source files, puts them in this build path directory, and then builds there. So you can get odd situations sometimes if you change a file. When I first started writing this script, I was generating the version.h in with the source files, and it was behaving strangely. It didn't always work, and I researched it a bit more, and I discovered that the Arduino build tools are actually taking a copy of all the files into a working directory and performing the build there. So that's what this does. It puts this version.h there. Now, in order to keep IntelliSense happy, we might have to create a template placeholder version.h file, but we'll cross that bridge when we come to it. Anyway, this is our board.txt, and that hooks that step into our build process. Now, here's a gotcha. You have to close the solution and reload it, because that board.txt file is only picked up when the solution is loaded. So we're going to close the solution, and we'll build that again. Is okay. There's our command executing right there. And normally I would move this build directory to be somewhere inside the solution folder, but that's not essential for showing what I want to show. So VM builds, temp VM builds, and then our project, and then okay, Maker Wi-Fi 1010. So in here it be in debug, because we're doing a debug build, and yes, there we go. So now we've got a version.h, and if I open that file up, okay, there we go. And so you can see that that's generated const expret auto semantic version equals, and that's string, and also major version and minor version. Hash include version.h. Now notice that IntelliSense doesn't know there's a version.h file. Okay, so this is something we'll look at in a minute. So that's gonna look like an error to Visual Studio because it thinks the file doesn't exist. So what we'll do in our loop, no, not in our loop, in our setup, we will just go. Now we're not getting IntelliSense here, which I had hoped we would. So what we can do is we can take a copy of this Version.h file and we can drop it into our directory. What we can do is we can click the Don't Lie to Me button up here in Visual Studio, and that will show us now that that file exists, but it isn't part of the project. So we'll now include it in the project. Okay, include in project, and then we can click off the Don't Lie to Me button, and that will now appear in header files. So we can edit this Version.h, and we can put in here some default, okay, so unversioned or something like that. Okay, and we can put 00 for the other version strings. Right, so that's like a placeholder for that file, which will just allow to be there. Now notice that this is no longer giving me an error. Okay, so now we should be able to access this semantic version property that we've created. Okay, and that one we've got full IntelliSense for that. Okay, and so it's just print there, and I won't bother doing the major version and minor version because you can see the principle in play. And so now I'm going to rebuild that, and we can look at the output screen, and once it starts to build the project code, there it goes, it's running our PowerShell script there, and alright, so that build succeeded, used 5% of the available code space. And then what we can do is we'll actually download that. Let's just make sure that we've got the right COM port selected. Yeah, no we haven't. So the Maker 1010 is on COM6 there, and we will go ahead and download that solution to the board, and we can open the serial monitor. On the Maker 1010, the serial port is actually a USB port, so it's a virtual serial port, and if you use it a bit quickly, it hasn't initialized yet, so you don't always see your output. So what we can do to alleviate that is we can stop that running, and then one of the other nice things about VisualMicro, in fact, if I dock that under here we go, perfect. Now one of the nice things about VisualMicro is it sort of gives you breakpoints, okay, but not really. So you can set a breakpoint, and then when I run that, because I've got a debug build and I've got debug set up here, if I build and download that solution, and there's the build happening. Now VisualMicro actually injects debugging code into the Arduino sketch, and it's not debugging like you get in Visual Studio. It's kind of rudimentary, but it's better than nothing, and it's a lot more than you get in the Arduino IDE. So let's see what happens. Okay, launching debugger, and okay, so on my right screen now you can see it says paused at line 11 in setup. Okay, so it's kind of a nice little approximation of a breakpoint, and then in order to continue execution you need to click this continue button here. So we'll click that, and then there you go, in our output window, there you go, so 010 alpha 0. So that version string has overwritten what we put in our Version.h file. So you recall that in there was unversioned and 00, and in our output down here we got 010-alpha.0. Okay, so that is what I wanted to achieve. So now anytime I commit my code, my version string automatically updates. And to demonstrate that, if we go into Team Explorer and look at changes, I'm just gonna say here added automatic versioning based on GitVersion. Okay, that's my commit message. So commit staged. So that's created another commit into PowerShell again. Then you can see I get a new git status, and actually if I put the git status command, okay, that's been modified, that's fine, but that's a third-party library that I'm not going to commit. So so if we just put in here git version again, then you can see that we're still on 010, but now we've gone up to -alpha.1. Okay, and the full semver here 010-alpha.1 instead of alpha.0. And just to prove that's worked, we will go ahead and run that code again. There's the code loading. Okay, and we've hit our breakpoint. Oh no, we haven't. Yes, we have. Continue, and okay, 010-alpha.1. Okay, so that firmware, that Arduino sketch from that point on will be completely automatically versioned based on our git commit history. And if you use a suitable branching model, and I'm using Git Flow, you can use GitHub Flow or any of those, then you'll find that GitVersion makes intelligent decisions about that. So for example, if you create a feature branch, you'll be on 010 dash and then the name of the feature branch dot something, or if you're on a release branch you'll get a -beta dot something, and if you're on the master branch you won't get a pre-release tag at all, you'll just get 010. So it follows all the correct rules of semantic versioning, and it's jolly good. And before I go, I just wanted to give one more nod to VisualMicro, because this is, if you're an Arduino developer and you haven't tried this, man, you should try it. It's an eye-opener. It makes development so much easier. Here, for example, is my sketch that I've just been compiling, this .eno file, and notice here I've got a references node, and under that you can see that I've referenced this library called Restfully. Okay, and that's actually in my solution. So you can actually create local libraries here as projects in your solution. You can also create shared code projects, and you just reference them from here just exactly as you would in a C# or Visual Basic project, and that works really, really nicely. All the IntelliSense works and everything. So for example, if I wanted to hash include, now one of the files in Restfully is endpoints.h, and you can see IntelliSense has picked that up right away. Okay, and it should be angle brackets, because not restfully. Let's go with endpoints because that's the one I'm going to end up using. Okay, and then I believe that uses a namespace. Okay, but as you can see, I'm getting IntelliSense now, and VisualMicro just figures all that stuff out and makes development much easier. You get IntelliSense as you're editing. The editor does lovely color syntax highlighting, and I've also got ReSharper C++ edition, so I've got all the power of ReSharper because that works in Visual Studio. So for example, if I wanted to rename this setup function here, then in just Control R, ReSharper should pop up and offer me the rename dialog, and that's smart enough to rename across whole projects, whole solutions. So you get all the power of ReSharper if you've got that, and if you are serious about developing for Arduino professionally, I think you really owe it yourself to get a tool like this, because struggling with the Arduino IDE is about as much fun as pulling teeth, to be honest. So there you are. I've covered everything I wanted to cover today, and so we've covered VisualMicro and what a great tool that is for working in Visual Studio. We've covered GitVersion for automatically versioning code based on Git commit history, and then we've covered how to wire that up into a Arduino solution and actually get that working as part of your build process, and this will work fine in the Arduino IDE as well. There's no magic here that depends on VisualMicro, so this is a completely portable solution. So that's it. I've been Tim from Tiger Astronomy. Thanks for watching.